In this section, we're going to cover routing problems and graphs. If you have a textbook, this is chapter 5, lessons 1 and 2. There are lots of examples of how you could use this type of problem in your life. Those of you writing this down, I would encourage you to write down the title. I would encourage you to write down some examples that you could use a routing problem or graph to solve. For example, a mailman would use it, trying to figure out their different routes. A bus driver would use it, going from one destination to another. Police officers have to use routing problems when they're navigating through a neighborhood or figuring out high crime areas. If you drive for Google Maps, you have to know where to drive your car. So these are all examples of routing problems. The graphs we're going to do are not your typical XY graphs. They're going to look totally different. You do not need to write this chart down, but basically you use a routing problem when you take a good or a service to a destination. And there are some other examples in there as well. We didn't talk about newspapers or recycling, but all these problems use routing. Again, you do not need to draw this graph. Let's go through a couple of vocab terms to know. The first one is called a graph. A graph is simply a picture of vertices and edges. Of course, if at any point in the video, if I'm going too fast, feel free to pause, rewind, watch as many times as you want, and come to class next time with your questions. I'll be glad to help you out. A vertex is simply a dot. If you have more than one vertex, it's called a vertices. A dot where two or more edges meet. An edge is simply a line, but it doesn't have to be straight. And make a note to yourself that it does have to connect at least two vertices. A loop is the last term to know. This is where an edge connects a vertex back to itself. Now, I think those vocab terms, writing out a definition is pretty difficult to know and memorize. What I would do instead is try to help solve by looking at a picture. I think pictures are a lot easier. So let's take a picture. So this is what a graph of a routing problem is going to look like. So first of all, we have several vertices in here. We have some lines connecting them. This is an example of a loop. Notice how this line leaves vertex E and then comes right back to vertex E. That is called a loop. Down here at the bottom, D and C have a special name. It's called multiple edges. They're called multiple edges because there's multiple, more than one, way to directly connect those two vertices. Now, for example, B and C are connected because B is connected to C. You can also technically get from B to C by going from B to A to D to C, but there's only one way that directly connects B to C. That's this edge right here, so therefore BC is not a multiple edge. A multiple edge means there is more than one way to directly connect two vertices, this edge here and this edge here. Notice how some of our edges are straight, some of our edges are curved, but they're all considered edges. So the question asks you to name the vertex set. Then you're listing all the vertices. Your vertices are A, B, C, D, and E. If the question asks to name the edge set, you would list all the edges. It helps me if I go in order. A, B, B, C. Notice you have C, D not once but twice. We list it twice. Again, that's our multiple edge. Then we have DE. We have BE. If you call it EB, it's fine. The order of those letters doesn't matter. They don't have to be in alphabetical order. We have AD. And then finally, we have our loop. The way we write our loop, people get this confused a lot, is we need to write both where it starts and where it ends. So the loop starts at E and it comes back to E. So we write it out as loop EE. If you write just one letter, it's a vertex. So make sure when you write a loop, you write both letters. So another reason you could use this is because if you're a visual person, this can help you really see information a lot easier than telling you a really complicated and convoluted story. So let's take, for example, this picture at the bottom. So this is a picture of who went with who to prom, who danced with who at prom. So in this picture, it's pretty easy to tell that it looks like Jordan danced with two people. He danced with Cassie and he danced with Katie. Wayne danced with Cassie and Katie and Natalie. So if I asked you, who do you think the couple was at this prom? You would go over here to the side and say, it looks like Jeter and Michaela are the couple because they're only dancing with each other the entire time. So graphs are a great way to figure out some data that you can look at in a picture, which makes a lot more sense sometimes. So let's go and do one more together. So let's practice drawing a graph with these requirements: 4 vertices and 8 edges. So let me help you get started with this. What I would do first is I would start by drawing my 4 vertices. It doesn't matter how you draw them. You can put them in a box. You can put them in a straight line. It doesn't really matter. I'll put A up here. I'll put B over here. I'll put C down here. I'll put D over here. Again, if you want to put them in a different order, you can. If you want to change your shape, you can. It doesn't really matter. You're drawing this on your own. You have 8 edges, so it does matter how you connect your edges. I want to connect A to D. So I'm going to draw a line connecting A to D. I have another A to D. That's called a multiple edge. So I'm going to draw another line connecting A to D. So continue with your shapes. It also helps me if I mark these off as I go. That way I know which ones I have and haven't used. And see if you can continue the rest of the shape. There is one loop in there as well. So I encourage you to pause the video and see if you can figure out what the right answer is. Hopefully by this point you've got it figured out. My answer looks like this. Your answer might be slightly different, but you can tell right away that it looks like BC is connected one time, D is your loop, AD is your multiple edge, so is AC. Multiple ways to draw this graph, but that is a brief intro on routing problems in graphs and how we can use this in our class. We'll get to more complicated concepts tomorrow, but for now, we'll stop there.